Chapter 3.3 Notes, Properties of Functions, page 5. Sorry for the typo up top. Example 9. So a little bit of what we did on page 4. Again, we're kind of combine that negative and decreasing. Just make sure that we are clear on the differences between them. So, on what intervals? A. Is the function negative? So we're going to go red for negative. Here's the thing. Under 0, 0 doesn't count. So all of this is negative. It goes up to here. All of this is -2. So it's really easy to want to say this is negative between -3 and +1. The problem is right here at 0, we've got this value here, 0, 0. That output of y is 0. It's not negative. So when we list this, we have got -3 to 0, parenthesis there, parenthesis on the other side, 0 to 1. Notice here, though, we have got that closed circle at 1. We can include 1. The value when x is 1 is going to be negative. So there's our negative. Also asks B, on what interval is the function decreasing? So reading left to right, where is our function going down? So here it goes down. Oops, that's not a curve. Here it goes down to -2. So we are decreasing here. Between -2 and 0, it's increasing, it's going up. And then at 0 again, it starts decreasing. 0 to 1. So the function is decreasing from -3 to -2, and then again from 0 to 1. Notice here we have the parenthesis on 1. Again, we're talking increasing, decreasing. That point can't be increasing or decreasing at a point. It's got to be on an interval. Average rate of change on -2, 0. So we've got this point right here, -2, -4, and then we've got the point 0, 0. So right endpoint, left endpoint. So there's my y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 0 minus, we have a -4 here. And 0 plus 2 is 2. 4 over 2, we get the average rate of change, or the slope between those 2 points is 2. The average rate of change on -3, 0. This is a little funky. So I've got this point, 0, 0. But notice up top, that -3 is not included in the domain. So this here is a problem because we don't actually have a function at -3. So unless both of those endpoints are included, we cannot find an average rate of change. So cannot find slope. F of -3 does not exist. The minimum value of the function, the minimum value, it's going to be the very lowest y value this takes on. Our minimum value is going to be y equals -4. Again, that happens at 2 places. That's not what we're being asked. We're just being asked for the very lowest value. The zeros of the function, again, that's where y equals 0. And that happens at x equals 0. Part 4 here, we're going to use a graph to locate the absolute maxima and minima. So we have got relative maxima and relative minimum. Those are the points that are larger and smaller than anything close. Okay. We can also have an absolute maximum and minimum, and those are the largest and smallest on the entire interval. So let's take a look at what we got here. We have an absolute maximum here because that value is larger than anything else. We have an absolute minimum here because that is smaller than anything else. Notice here we have an open circle, and also this one right here could be considered a relative minimum because it's the bottom of a valley. It's smaller than everything close to it, everything in the immediate neighborhood. So also, for the middle graph, we've got one that is strictly increasing. That's a linear. We got an absolute minimum at one endpoint and an absolute maximum at the other. Nothing in the middle there. Okay. Our third graph right here, we have got, and we're going to make this a closed-in circle. This is going to be a relative maximum. You can think of it as the top of a hill. It's larger than everything close to it, but it's not actually the largest value on the interval. So we can see as we look to the right, all of these values that are larger, but in terms of what is close to x sub 2, that is the peak of a hill. So it's larger than anything close to it. Over here, largest on the entire interval, that's our absolute maximum. We have an absolute minimum down here. By default, it's also a relative minimum. It's smaller than anything close, but it is the smallest value, smallest output value within that interval.